All right, our DLO for today is solving multi-step equations in different representations. So please make sure that you have that written at the top of your paper. We're going to be looking at a couple problems out of our packet. So we're on this page. It's called Why Aren't Flowers Sold at a Monastery? We're going to look at this first problem right here. And so we're going to try and solve this one together. So I want to look at the first equation. So let's look up here at the top. I'll zoom into it. Up here at the top, we have this equation. It says 9 divided by x divided by 9, x divided by 9 plus 16 equals 5. And then if you look over here at the side, we have all of these answers for number 1. And so essentially, if I can bring this back over here, essentially what we're going to try and do is we're going to try and pair up some of these answers that we have over here in these blanks so that we can correctly match which step of the process we're on. And so for the first one, it says x divided by 9 plus 16 equals 5. If we look at this next part down here, I see that they are subtracting 16 from one side and subtracting 16 from the other side. So if I look over here in my answers for number 1, I think, okay, they're subtracting. I see W is addition, O is subtraction, I is multiplication, K is division, T is simplifying. So I'm going to go with O, which is the subtraction property of equality, because it makes sense that if you're subtracting one thing from one side, you subtract the same thing from the other side, and therefore it is the subtraction property of equality. So I'm going to write an O right here. All right, let's look at the next step. I see that over here on the left-hand side that they got rid of this plus 16 minus 16 because those are additive inverses, so they cancel. And then over here they simplified. They got 5 minus 16 equals negative 11. And so I would just call that simplifying. That's a simplifying process. So that's going to be a T. All right, so far so good. Now from that step to the next, let me erase some of this so we can have a cleaner slate. From that step to the next, I look again, and I see that x is being divided by 9. If you look here in this step, I see x is being divided by 9. And so from this step to the next one, essentially what they did is they want to do the inverse operation of divided by 9, so they multiplied by 9 on both sides. So they multiplied on the left-hand side, they multiplied by 9 on the right-hand side. So if I look over here at my answers, I see, again, W is addition, O is subtraction, I is multiplication. So this is going to be an I. I should probably make that into a better I. There we go. So we have OTI. And then last but not least, on this left-hand side, 9 and 9, those are called multiplicative inverses, so I'm just going to cancel those. So I get x on the left-hand side, and then negative 11 times 9 is negative 99. So again, that last step, we didn't really change anything, we just simplified everything. So we get another T. So my complete answer would be OTIT. And that's how you do that problem. All right, so this is the next page that we're going to look at in your packet. It says Additional Practice 1-4 up at the top. It's on page 21 of the packet. And so I think you guys are good with some of these first ones. We're going to skip down to some of these ones with fractions because I know that fractions are not everyone's favorite. And so we're going to do one of these together with fractions so that you guys can kind of have an idea of how to do them. So let's look at number 9 together. Number 9 looks like one of the more difficult ones on this page. So I'm going to zoom into number 9 for us. All right, so here we have number 9. I see fractions everywhere in my problem, but essentially I see negative 4/5 t plus 2/5 equals 2/3. And so I want to see what's happening to t. So I'm just going to write myself some notes over here. So the first thing that's happening to t is that, here, let me write it in a different color. Maybe it'll be easier to see if it's in black, or maybe dark blue. Dark blue would be nice. So the first thing that's happening to t is that it's being multiplied by negative 4/5. And the second thing that's happening to t is that it's being added by a 2/5. So I'm going to say add 2/5. And so in order to solve these types of problems, we need to do the opposite or inverse operation in the opposite order. So the first thing we're going to do in order to solve it is we're going to do the opposite of adding 2/5, and we're going to subtract 2/5 from both sides. And then after that, we're going to do the opposite of the first one. And so the opposite of the first one is going to be divide by -4/5. All right, so again, the first thing that happened was we multiplied, then we added 2/5, so we're going to do the opposite in the opposite order. Subtract then divide. So I'm going to erase those steps, so write those down if you don't have those down yet, but I'm going to erase those steps so we have a little bit more room. And we're going to start. So the first thing we said we were going to do is we said that we were going to subtract 2/5 from both sides. So I'm going to subtract 2/5 from the left, and I'm going to subtract 2/5 from the right. So minus 2/5, that's supposed to be a 5, minus 2/5. All right, so over here on the left-hand side, 2/5 minus 2/5, those are additive inverses because they add to 0. So those are going to equal 0, so I can just simplify by getting rid of those. On the right-hand side, I see that it says equals 2/3 minus 2/5. Now we have a problem, so here's a little review of fractions for us. We have 2/3 minus 2/5. Now think to yourself what the problem is with that. And hopefully you said that they do not have a common denominator. So because they don't have a common denominator, we need to get one. So I'm going to think of the least common multiple between 3 and 5, or the least common denominator that I can think of between 3 and 5. If you can think of it in your head, that's great. If you can't, you should start listing off all the multiples of 3. So there's 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15, so on and so forth. And then the multiples of 5. 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, and then voila, we have a match. So the least common denominator, or the least common multiple between 3 and 5 is 15. So I'm going to have to figure out a way to get both of these denominators to equal 15. So let's see, over here on the left-hand side, I'm trying to think to myself, what can I multiply times 3 to get 15? And the answer is 5. And if I multiply by 5 on the bottom, I also have to multiply by 5 on the top, because now 5 over 5, those are multiplicative inverses, and so they cancel to 1, or they reduce to 1. And it's okay to multiply anything times 1, because 2/3 times 1 is just 2/3. So we're not changing the equation at all, we're just looking at it in a different way. And then over here on the right-hand side, I'm trying to think what I can multiply times 5 to get 15, so I have 3, and again, I want multiplicative inverses, so I'm going to go ahead and put a 3 on the top. So when I simplify this, I get 5 times 2 is 10, 5 times 3 is 15, and then for the second term, I get 2 times 3 is 6, and 5 times 3 is 15. So now that we have a common denominator, 10 over 15 minus 6 over 15, I can subtract the numerators and then keep the denominator the same. So 10 minus 6 is 4, divided by 15. Perfect. So all of that work was to go ahead and simplify this part of it. It said 2/3 minus 2/5. We wanted to simplify that. And so all of this work over here on the right-hand side was to show that 2/3 minus 2/5 is in fact 4 over 15. So I'm going to go ahead and rewrite that over here for us. So looks like we're going to run out of room over here. So I'm going to do some rearranging. I'm going to erase all of this work. So make sure you have all these fractions written down. So I'm going to erase all of this. All right. And then I'm going to go ahead and I'm going to say, let's bring our equation up here so that we have a little bit more room to write on. So on the left-hand side, I still have -4/5 t. All right, that 2/5 and -2/5 canceled because they were additive inverses, equals, and then we just found out that 2/3 minus 2/5 is in fact 4/15. So I'm going to put 4 over 15. Beautiful. Now, if you remember back to the beginning, look back at the beginning of this problem in your notes. And so we did the first thing where we said that we wanted to subtract 2/5 from both sides. And now we want to do that second thing where it says we need to divide by -4/5. But, as you probably know, we don't like dividing by fractions. So instead we're going to use this little algebraic trick that we know. So instead of dividing by -4/5 on both sides, we're going to multiply by the reciprocal. So let me do this in red so we can see it a little different. So we're going to multiply by the reciprocal. I'm going to multiply by negative 5 over 4 because that's the reciprocal of 4 over 5. I just flipped it upside down. And if I do that to one side, I also have to do it to the other so that I can balance our equation. So I'm also going to multiply by negative 5 over 4 on this side. So now this is perfect. On the left-hand side, these are multiplicative inverses. So I notice that the 5 and the 5 are going to cancel, the 4 and the 4 are going to cancel, and I have a negative and a negative, which makes a positive. So on the right-hand side, I'm just left with t all by itself. So I have just a t. And let's see about this right-hand side. Sorry, that was the left-hand side. So I have on the left-hand side, I just have t. On the right-hand side, let's see what happens. I have 4/15 times negative 5/4. So instead of just multiplying straight across, I'm going to do some simplifying first because it's going to make my answer too big if I don't simplify first. And so I want to make my life easier. So I'm going to look for factors that the numerator and denominator have in common. So I notice that they both have a 4 in the numerator and denominator. So because they both have a 4, I'm going to cross off the 4's because they simplify to 1. Those are called multiplicative inverses. 4 divided by 4 is equal to 1. And then I see that I also have a 5 and a 15. And I know, because I know my multiplication tables really well, I know that 5 goes into both 5 and 15. So negative 5 divided by 5 is negative 1, so I'm left with a negative 1 in the top. And 15 divided by 5 is 3, so I'm left with a 3 in the denominator. So if I look at my numerator, the only number that's left in the numerator is negative 1, and the only number that's left in the denominator is 3. So my final answer is t. I have t isolated now, t is all by itself. My final answer is t equals negative 1 divided by 3. And let me put a bigger box around that so you guys can see that that's my final answer. Let me make this bigger. There we go. Here we go. T equals negative 1/3. That's my final answer. And so maybe you want to go back and play that again if it was a little confusing or if you got any steps mistaken or anything. So go back and play that again just to make sure we have it right. All right, and then the last one I want to look at for today is a word problem. It's from the very next page on page 22. It's from a problem-solving worksheet, and it's number 3. It says, Maggie's brother is 3 years younger than twice her age. The sum of their ages is 24. How old is Maggie? So let's look at this together. We want to know how old Maggie is. So I'm going to assign a variable that talks about how old Maggie is. So I'm going to put M for Maggie. So equals age of Maggie. So when we solve for M in our equation, we're going to have our answer. How old is Maggie? M is the age of Maggie. So it says Maggie's brother is 3 years younger. 3 years younger. So let me think about this. If I'm 15 and my brother is 3 years younger, that makes my brother 12. Okay, how did I get that? Well, 15 minus 3 equals 12. So we don't know if Maggie is 15 or not, but let's just say that Maggie's age minus 3 is how you figure out that part. So it says Maggie's brother is 3 years younger than twice her age. Oh, we forgot about that twice her age part. Where does that come in? So I could see some people getting confused about where to put this twice part. First of all, what does twice mean? Let's see, twice means 2. Okay, good. So we're multiplying by 2. So twice as much would be double. That's another word for it. But how do I put it? Do I put it like this with the 2 on the outside? Or do I write it like this? 2m minus 3. So let's read it one more time just so we can be clear about which one it's supposed to be. It says Maggie's brother is 3 years younger than twice her age. And so it is a little bit confusing about how the way it's worded. But when you learn first about how to convert from English words into mathematical language, we learn that when you have it written in this way, 3 years younger than, that key word is kind of than, it tells you where it should be. 3 years younger than twice her age means that we're trying to multiply the twice to her age first, and then he's 3 years younger than that, all right? And so we're going to go with the second one, 2m minus 3. So let me erase all of this work so far. And we're going to go back to 2m minus 3. All right, so 2m minus 3. That's how old Maggie's brother is, okay? So here, this represents the age of Maggie's brother. It says the sum of their ages is 24. The sum of their ages. What does that word sum mean? The sum of their ages? Oh yeah, that's right. Sum means to add. So if 2m minus 3 represents the age of Maggie's brother, and m represents the age of Maggie, if we add together those two, that would be the sum of their ages. And this keyword is, that's a really, really important word in math. And whenever you see that word is, it means equals. So equals 24. And there's my equation. I just set up an equation of how to figure out how old she was. So if we're going to solve this equation, we need to start by combining like terms. So I'm going to go ahead and I'm going to write this a little bit smaller because right now it takes up too much room. So 2m minus 3 plus m equals 24. Make sure you have that written on your paper. 2m minus 3 plus m equals 24. Now notice that I took away the parentheses. The reason I took those away is because nothing was being multiplied to them, so nothing was going to change what was in the parentheses. The only reason I grouped those together in the first place was because I wanted to show you that that represented the age of Maggie's brother. But now that we're trying to find the sum, I'm just going to add them together. So I look for my like terms. I have a 2m and an m. So 2m plus m is 3m. So I have 3m minus 3 equals 24. All right, and then I want to get all my constant terms to the other side. So right now I'm gathering all my variable terms on the left, and I want to move my constant term over to the other side. So because I'm going across the equal sign, if you look up above, I could combine like terms because 2m and m were both on the same side of the equal sign. Down below, because I'm going across the equal sign now, whatever I do to one side, I also have to do to the other. And that's why we're doing the opposite. So the only time you do the opposite operation or the inverse operation is when you're going across the equal sign, when you're crossing over. So these are called additive inverses. They equal 0. So I have 3m equals 24 plus 3 is 27. All right, and we are almost done. We have one more step. So right now 3 is being multiplied times m, so I'm going to divide by 3 on both sides. And I get, these are multiplicative inverses, so they simplify to 1. And I get m equals 27 divided by 3, which is 9. Now because this is a word problem, yes, our answer is 9. But because it's a word problem, it was asked to us in words, I want to respond in words. So instead of just saying m equals 9, I want to write a sentence back. I want to say, Maggie is 9 years old. And that will be our final answer. So whenever you're given a word problem, if they ask you in words, respond in words. So your answer should be in words as well. All right, now that's going to be it for today. So make sure you have those 3 examples in your notes, and we will see you tomorrow.